All right, hello. This is day 9, and uh, yeah, hopefully it's not too bad. Um, these caves seem to be like lava tubes. Parts are even still volcanically active. Small hydrothermal vents release smoke in the cave, slowly cells like rain. We can model how the smoke flows through the caves, on people to avoid it, be that much safer. Submarine generates a height map of the floor of the nearby caves. Smoke flows to the lowest point of the area it's in. For example, consider the following height map. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest the location can be. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations, up, down, left, and right. Locations on the edge or corner of the map have 3 or 2 adjacent locations, respectively. Diagonal locations. In the above example, there are 4 low points, all highlighted. 2 are in the first row, a 1 and a 0. Um, and in the above example, there is 4 low points, all highlighted. 2 are in the first row, etc. The risk level of a low point is 1 plus its height. In the above example, the risk levels are those. Sum of the risk levels is that. Find all the low points. What is the sum of the risk levels of all low points in your height map? All right. Seems reasonably straightforward. Let me do that. Um, and so we have a height map. Okay. Def in itself rows, which is an iterable of uh, strings. Okay. And so I need to import iterable. Okay. And we'll just say self rows equals rows, or I'm just going to say self.map equals rows, self.numRows equals len of rows, and self.nc equals len of rows 0. And so that should be, yes, self.map equals this row for row in rows. Well, I'll just convert it that way, and that will make my types work out. And then I can use len of self.map 0. Okay, okay, I don't want that. And def neighbors and so let me get iterator and tuple in here. Okay, so this is fun because Copilot wrote this code for me, and let's check and make sure if it's right. So given a row and a column, what are the neighbors for drdc and -1 0 1 0 0 -1? Okay, if r plus dr is between 0 and the self number of rows, then 0 plus that yield that. Okay, so that's right, and Copilot wrote it for me, which is handy. I mean, obviously I could have written it myself, but it's faster for Copilot to write it to me. And and so what did we call this? We want to find the low points. And that's not right. Is low point self let's see. So return all self map RC is less than or equal to self map R underscore C underscore for R underscore C underscore and self dot neighbors RC. So that seems right. Easy enough. And then the risk level of a low point is 1 plus its height. And so let us go back and do risk level, and see int goes to int, and the risk level of a point is 1 plus its height. Okay, so it was able to figure that out. And now let's say total risk level self goes to int. Oh, let's see. I think it was going to do the wrong thing. It's going to do the wrong thing. So actually, let's total risk level. Let me change it of low points and see if that is enough to get it to figure it out. Okay, so return self risk level RC for R in range self.nr, for C in range self.nc if self dot is low point RC. So so it's funny, like I am someone who is independent of Copilot. This is not right because actually, let me change this because equals int val for val in row for row in row. So I'll map it to int up here because I didn't do that ever. And now that will fix that bug here that it was not behaving properly. Anyway, what I was saying before I fix that bug is that I'm big into naming things in a helpful way and making code readable, right? And so we can see with Copilot is by giving the function like a very explicit name, Copilot was able to write it. And if I'd given the function like some vague name, it would not have been able to write it. So yet another reason to HM equals height map raw. Seriously? Oh, because I didn't put underscores on init. Okay. And then I want to assert that hm.total risk level of low points equals, I don't think it's 114, I think it's 15. Okay, so let's do that. And this is going to be another one probably where all right, I'm just going to do it this way. Raw, which is a string, for row in raw dot split lines. Let's try it like that. Okay, so that worked, and now so in part 2 they're going to do something to like blow me up where my brute force method is not going to work, but that's okay. We'll deal with that when it happens. So if name is main, nope, raw equals open data 09. It really wants me not to have that data directory. Dot read hm equals height map raw print hm total risk level of low points. Okay, so let's run this, and it says 1,640. So let's try that. That's not the right answer. The answer is too high. So let us print self.nr self.nc, and then if ILP is it lower than its, so I'm wondering if that less than or equal to is wrong. If I think that's going to be the issue. Print self dot, well, let me just take a quick look and let me just change this and rerun it, because I think that's the issue. And if that's the point, Copilot kind of messed me up. Okay, so that's not right either. So let's look at this. But this one should be right. So, oh, that's the issue. And then I have a stray print statement somewhere. Okay, so let's try this one more time. 600. Okay, so let us try it again. That is the right answer. Okay, good. So obviously the issue was that I was checking for less than or equal to its neighbors. It needed to be strictly less than its neighbors. A basin, next you need to find the largest basin. A basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being any basin, and all other locations will always be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. The table above has 4 basin. The top left basin, size 3. The top right basin, size 9. The middle basin, size 14. And the bottom right basin, size 9. Find the 3 largest basins and multiply their sizes together. In the above example, this is this. Okay, so let's figure out. A basin is all locations that eventually flow downward to a single low point. So, basically, to find a basin, I go to the neighbors, and what I want to do is I want to, so I basically go everywhere until I find a 9, right? And same thing here, I go everywhere until I'm blocked in by 9s. And similarly, I go everywhere until I'm blocked in by 9s, and similarly I go everywhere until I'm blocked in by 9s, okay? And so what I want to do is find basins size is self, and it is going to be an iterator of ints because I'm just going to yield them as I find them. Or actually, find basin size self R and CN. So I'm just going to start doing that. Oh, be quiet, you dog. Okay, and so Josie, stop it. Well, I don't even know if you can hear that through my thing, but there's a dog that's barking very loudly. Okay, and then again I need and basin size equals 0. So while stack So let's see what happens. R comma C equals stack dot pop. Base and size plus equals 1. And hold on one sec. There's a dog walking up my street, which is making my dog go crazy because she thinks she owns the street, and she does not own the street. And M R, I'm going to call it C equals 9. So I'm going to assume that that the thing I start with is not it. And then for that, if MRC is not equal to 9, stack append R comma C, and then return base and size. Okay. Right, the way I wrote this, it's going to be an int. So basically, I clobber things with 9s, and then when I find new neighbors that are not 9s, I add them to the stack to be explored, and so on and so forth. And so def all basin sizes self, which is a list of ints. So first, let's do all low points. Let's see if Copilot is smart enough to figure this out. List of tuple int returns all low points. Return RC for self-arranged and RC arrangency if self is low point. Okay, good. So that's right. All basin sizes. And turn self.basin size RC for RC and self.all low points. Okay, that's good. And so now I want to assert that set of hm dot all basin sizes equals and let us go check is 3, 9, 9, and 14. 3 actually assert that I'm not going to do a set. Sorted equals 3, 9, 9, and 14. And let me do this. Right, because I have to do 2 equal signs. Okay, so print hm dot all basin sizes. So let's run this and see what I did wrong. 3, 10, 19, 11, where it's 3, 9, 9, and 14. Okay, so for RC and hm dot all low points, good. So let's see what it does wrong. So at 0, 1, it finds 3. At 0, 9, it finds 10. At 2, 2, it finds 19. And at 4, 6, it finds 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let us debug one step even further. For find basin size, print RC MRC. You know what? I think the problem is that I'm getting things on here multiple ways, and I'm not keeping track of that I already saw them. So I think that's going to be the issue. And let's say visited equals set. And I'm going to do it this way. Visited equals RC. If that, and RC not in visited. So now I'm keeping track of where I've been, so I don't add the same things multiple times. And assert sorted HM dot all basin sizes equals, and what was it? 3, 9, 9, 10. Is that right? No, I don't think that was right. I think it was 3, 9, 9, 14. So let's go back and fix that. Okay, good. So that works now. And so ABS equals sorted.hm, and then let's say ABC equals ABS minus 3. So we take the 3 biggest, right? Print A times, you know what, I'm going to write this as a function so that I can do a unit test for it. And let me see what they called it. 3 largest basins product. Def 3 largest basins product. Product of the 3 largest basins. No, so that's doing the wrong thing again. All basin sizes equals self.all basin sizes. And sorted all basin sizes. Here I'll do reverse equals true so that I get the smallest. And then once I do that, I can do all basin. That's good. And so here I'll assert that HM 3 largest basins product equals, that's very smart of it. Wow, good job. So let's run that one. And print HM dot 3 largest basins product. So let's run that, and it is 987,840. So let us copy that and try pasting it, and that is the right answer. Okay, so some dumb mistakes here. One dumb mistake was obviously checking for less than equal to rather than less than. The other dumb mistake was not keeping track of places I've already visited and adding them to the thing twice. So obviously Copilot is not going to save you from yourself, but you can see also that, with smart function names and smart doc strings, Copilot did some good things. So, yeah. Hello. And so, I think that's good. And yeah, so I will see you maybe tomorrow. It's Friday. I may not do it Friday. I have some stuff to do. I may just do 2 of them on Saturday. But regardless,